Hello, in this video we'll be looking at how to integrate functions of ax plus b based upon the fact that we already know how to integrate functions f of x. So a very quick reminder of what you already do know. You know how to integrate x to the n, e to the x, 1 over x, cos x, sin x, and then sec squared, cosec x, cot x, cosec squared x, and sec x, tan x. So there are 3 steps to this process. The first one is to identify what the integral is based upon. I mentioned the 9 examples that we've already met in the previous slide, from which we will identify what y would be a multiple of. We then let y equal our suggestion, differentiate it, and compare, and then modify our answer as a result. Please note, as it says at the top right, I would only use this method after integration by substitution was intuitive to me. So I'm not recommending this as a first approach to integrating new integrals. Let's imagine that we want to integrate cos of 3x plus pi with respect to x. Okay, now we already know that the integral of cos x is sin x. So if we've got dy by dx equals cos 3x plus pi, and we're looking for the integral y, then y we would expect to be some multiple of sine of 3x plus pi, because the integral of cos is sine. So let's let y equal k sine 3x plus pi, some multiple of sine 3x plus pi. When we differentiate it again via the chain rule, we get 3k cos 3x plus pi, and comparing what we're asked to integrate, cos of 3x plus pi, with what we've got here for dy by dx, 3k cos 3x plus pi, 3k is equal to 1, so k is a third, and that means that the answer is 1/3 of sine 3x plus pi, i.e. taking that third and substituting it for k in our let y equals k sine 3x plus pi. Let's take a look at another example. This time we want to integrate e to the 8x minus 3 with respect to x, and we know, as it shows you top right, the integral of e to the x is e to the x. So if we've been given, say, dy by dx is equal to 8x minus 3, then the integral y we would expect to be some multiple of e to the 8x minus 3, i.e. it's going to look the same because the integral of e to the x is e to the x. So let's let y equal some multiple of e to the 8x minus 3, i.e. k e to the 8x minus 3. When we differentiate that by the chain rule, we get 8k e to the 8x minus 3, which means if we compare that with the thing we're integrating, 8k is equal to 1, which means that k is 1/8, and therefore the integral of e to the 8x minus 3 with respect to x is 1/8 of e to the 8x minus 3 plus c. This time we're going to integrate a polynomial with respect to n, and we've got 2x plus 5 to the power of 9 to integrate with respect to x. Now we know that when we integrate x to the n, we get x to the n plus 1 over n plus 1, i.e. the index has increased by 1. So if we've got dy by dx equals 2x plus 5 to the power of 9, then the integral of that we would expect to be some multiple of 2x plus 5 to the power of 10. So let y equal k times 2x plus 5 to the power of 10, i.e. some multiple of 2x plus 5 to the power of 10. Then we differentiate it via the chain rule. Essentially what happens is that we're timesing by the coefficient of x in the brackets and the index 10. That gives us 20k times 2x plus 5 to the power of 9. So 20k is equal to 1, comparing it with the original. So k is a 20th, and the integral is 1/20th of 2x plus 5 to the power of 10. Notice, by the way, that you could differentiate each of these answers to show that you get the original question. This time we've got to integrate 20 over 4x minus 3 dx, which may not look like it, but it's an example of 1 over x being integrated to give us log x. So if dy by dx is equal to 20 over 4x minus 3, then in this case we're going to assume that y will be some multiple of the natural log of 4x minus 3. So let's let y equal k log 4x minus 3. And then when we differentiate it again by the chain rule, we get 4k over 4x minus 3. Comparing that with the original, we have 4k is equal to 20, so k is 5, and that means that our integral is 5 log 4x minus 3 plus c. I remind you, I wouldn't do this like this the first time I ever met the idea. I would learn how to integrate by substitution first, until this was intuitive to me. Let's look at an example based on 6 to 9, which are the integrals of sec squared, cosec x, cot x, etc. So we've been asked to integrate 6 sec squared 3x plus pi over 2 dx. Now number 6 says that the integral of sec squared x is tan x, so I'm expecting the answer to this integral to be some multiple of tan of 3x plus pi over 2, because tan is the integral of sec squared. So again, I'm going to let y equal k times the thing I think it's a multiple of, tan 3x plus pi over 2. I'm going to differentiate it via the chain rule. That gives me 3k sec squared, 3x plus pi over 2. And comparing that with the original, 3k is equal to 6, which means that k equals 2, and hence my integral is 2 tan of 3x plus pi over 2. I'm going to finish off with 2 based on polynomials, but neither of which has a positive integer index. So the integral of 9x plus 1 square rooted dx, we would normally rewrite that as the square root of 9x plus 1 using the power of a half. So 9x plus 1 to the power of a half. Don't forget that if we integrate that, we would expect the index to be 3 over 2. So on that basis, let's assume that y is some multiple of 9x plus 1 to the power of 3 over 2, i.e. k times 9x plus 1 to the power of 3 over 2. When we differentiate that using the chain rule, we times by the 9 and the 3 over 2, and that gives us 27 over 2 lots of k times 9x plus 1 to the half. So again, comparing that with the original, 27 over 2k is equal to 1. So k is 2/27ths, and our integral is 2/27ths of 9x plus 1 to the power of 3 over 2. And then finally, the integral of 56 over 7x minus 8 to the power of 5. And note, some people might think that's a logarithm, but it's only going to be a logarithm if the denominator is linear, and it's not, it's to the power of 5. So we rewrite that as the integral of 56 times 7x minus 8 to the power of minus 5 dx. And as we know, when we're integrating polynomials, we add 1 to the index. So I'm going to assume that y will be some multiple of 7x minus 8 to the power of minus 4. So y equals k times 7x minus 8 to the power of minus 4. Differentiate it via the chain rule, and that means timesing by 7 and minus 4. That gives us minus 28k times 7x minus 8 to the power of minus 5. Comparing that with the original, minus 28k is equal to 56, which means that k is negative 2, and our integral is the negative of 2 over 7x minus 8 to the power of 4 plus c.